Hello dear students, welcome you back for lecture number 3 on the topic system of particles and rotational motion. So far in this topic we were able to understand what exactly is translational motion and rotational motion, and in the previous class we are also able to understand what exactly is the center of mass. So in today's class we are going to study very important application of this topic, which is torque, and along with the torque we will also study today a concept of angular momentum. So before we study angular momentum, let us understand what exactly is a torque. So let me write a definition. Torque, the turning effect of force along the axis of rotation, is called torque. And torque is denoted by this symbol. It's a Greek letter. Or in simple word, torque is nothing but it is a moment of force. Now please try to understand. In the very first lecture I had told you, okay, this topic relates with your linear motion concept, where we were considering the force, and the force and torque are quite similar. How they are different? Force we consider in a linear motion, whereas torque we consider in a rotational motion. Now what exactly is a torque? Torque is a turning effect of force. Now when you experience a turning effect, suppose this is a marker. It's a marker only, right? And if I pivot this with one end, and if I apply the force, so when I apply the force, this marker is tend to move in a rotational motion, or it is tracing one circular path. Now it is violating Newton's law, right? It is not exactly violating, but what Newton said, the body will always go in the direction of the applied force. I am applying force in this direction, so as a result marker should go in this direction. But what exactly is happening? When I apply the force in this direction, the marker is tracing a rotational force. It's giving you a turning effect. This turning effect of force is called as what? Torque. So torque and force are quite similar things. How they are different? This force we used in linear motion, and this force we use in rotational motion. You might have experienced torque in your day-to-day life most of the time. Like when you open the door, the one end of the door is pivoted. So when you apply the force, what happens? The door, it will go radial outwards or inwards. So that whatever force you are applying, that force is not giving an object a straight line motion, but that force is producing an turning effect. And this turning effect of force is called as what? Torque. Now it is quite clear that if you want to experience a torque, a body should be pivoted. Not necessary, but most of the time if the body is pivoted, then body will experience a rotational force, right? Now as I told you, not necessary it should be pivoted also. Like for an example, if it is pivoted, definitely it will experience a rotational force. What if the marker is kept in this direction, and if I just apply this force at this end, definitely it will also rotate. But what if I apply the force? See, if the case where the body is not pivoted, if you apply a force here, so what will happen? This marker will experience a rotational force. If I apply here, maybe in the anti-clockwise, here clockwise direction, here anti-clockwise direction, right? Because torque is a force and force is a vector quantity. We'll come back to its direction later, but understand the concept. But what if I hit the marker in this direction? For an instant I am hitting at the center of mass, so it will not experience a rotational motion, it will rather go in a straight line. So it is always convenient if you pivot a body at one end, or if you take one axis of rotation, if one end is pivoted, then definitely body will experience a rotational motion. Not necessary always it should be pivoted also, as I given you an example. Okay, so torque is also defined as what? Moment of force. Now how you give torque? Torque is a vector quantity which is given by R cross F. Torque is given by R cross F. Okay, so it is like, see here, if I pivot this body at one end, this end is pivoted, this is an axis of rotation, and if I apply a force here, so body rather going straight line, it will trace a circular path. This is exactly what it is called as a torque. Copy down the definition so that I'll explain the further things. Okay, fine. Here we go. Okay. Now, torque. How define torque? Torque is a vector quantity given by R cross F. R cross F. It is a very good example of cross product. I hope you have studied cross product and dot product in motion in plane topic. Okay, so it's a good example of cross product, and you know that cross product, the angle between two will be sine theta. The angle between them will be sine theta. Okay, and since all of you know it's a cross product, right? When you multiply two vectors and you get one vector quantity, then it is a cross product. Okay, if we are not able to understand this cross product concept, you have to go through the video which is in a motion in plane topic, where we have covered the concept of cross product and dot product. Now here we give n cap. N cap is what? N cap is the position vector which is perpendicular to the plane of R and F. Since it's a vector quantity, it is very important to represent with a vector. So this n cap is a unit vector which is perpendicular to the plane of the R and F. I hope you have studied cross product and dot product. If you have not studied, then it becomes very difficult, or else I'll tell you later. Okay, now please understand, the SI unit of torque will be Newton meter. The SI unit of torque will be Newton meter. Can you write it dimensional formula? Dimensional formula torque will be what? M1 L2 T minus 2. It's a vector quantity. Torque is a vector quantity. Now, torque depends upon what? This is very much important to understand. Like you might have experienced torque in your day-to-day life so many times. You might have gone to the bore well where the handle will be a little bit longer. Why it will be given longer? Because the turning effect will be more. Whenever the tire get punctures, right, what happens? You will be given a big rod to open that screw. Why the rod will be longer in length? So that turning effect will be more. Like for an example, you understand this. Suppose there is one rod and you need to rod, or in the sense there is a door which is to be opened. Now this one end is pivoted, this end is pivoted, right? Now, and let this distance be R. Okay, now I'll erase this. The distance is R here. Now when you apply the force, this torque depends upon what? That we are going to study. Now see here students, you want this rod to experience a rotational motion. Okay, so it depends upon where you apply the force. Suppose if I apply the force here, it will stress a circular path. If I apply the force here, okay, I need to spend more energy. Same happens with the door. When you open the door is given a handle at the edge so that you can easily open and close the door. Have you ever wondered why the handle is not given at the center? Why it is given at the edge only? Whenever the tire get puncture, you need to open that screw, and to open that nuts, not screw, nuts. So there will be given one rod or a bolt what we call, which will be of longer length. And when you open it from the, when you try to apply force from the edge, then it easily moves, right? Same happens with the bore well. The handle of the bore well will be longer in size. Okay, because when you apply the force here, if it is a bore well which is giving you water, okay, just imagine this. So you will always prefer to apply force in this direction and at the edge, not rather than applying force where the distance is less. Okay, so understand on what factors exactly the torque depends. So suppose I'll take this. Suppose there is one bolt. There is a bolt, okay, a longer length I will take. Okay, and with that bolt you need to open one nut. Okay, that is one nut. So always, without even knowing the physics, any common person will always apply force in this direction. Yes or no? The more the length, the more easily it can open. Yes or no? When you clockwise, it will open. Anti-clockwise, it will become tight. Okay, so this F, this torque, the turning effect depends upon the distance R. The more the distance, more will be the torque and more will be the turning effect. And it depends upon the magnitude of the force. Definitely, you need to apply more force. More force, yes or no? If you apply more force, more torque you will experience. Got it? Are you understanding? And it doesn't mean if you have more force and you apply in this direction, definitely the turning effect will be less. So it is always convenient to take larger distance, apply more force, and depends upon the angle between R and F. It also depends upon the angle between R and F. You see here, because all of you know what is cross product. Cross product is what? A cross B sine theta. Yes or no? It depends upon this factor theta. I hope you have studied what is cross product and dot product. If you are not able to understand dot product and cross product, then things become very difficult to understand here. All of you know what is cross product and dot product, right? When it will be maximum, when theta will be 90 degree, because sine 90 will be maximum. So it depends upon the angle also, on what angle you are applying. So how you can write here? The torque depends upon the distance, it depends upon the magnitude of the force, and it depends upon the angle. Okay, and this n cap is a unit vector for this torque. What is the work of n cap? It just gives you the direction. All of you are understanding? All of you are understanding? Okay. Now see here, understand this thing, concept of angle. Suppose, let me take that rod over that bolt, okay, where you need to apply the force. Suppose you are applying force in this direction. Suppose you are applying force in this direction. Definitely the turning effect will be less. If you apply that same force in this direction, definitely it will be giving you more torque. So here, if I draw this, this will be the magnitude, this will be the direction of the force. Are you understanding? Now this is the force. Now this force is a vector quantity. How can you resolve this force? Can I resolve this force into two components? Let this vertical component be F sine theta. Let this be theta, and this horizontal component, shall I take F cos theta? Are you understanding? Now which component is responsible for this turning effect? Definitely F sine theta. Definitely F sine theta is responsible for this turning effect, because you cannot have a turning effect because of this component. F cos theta is in this direction. You need to make this bolt a tighter. So what you will do, you will either make it clockwise or anti-clockwise. You will take it either up or down. Vertical components you are considering, you are not considering. You, whenever you want to screw anything, or whenever you want to open the door, what you do it? You open it outwards or inwards. You don't open the door along the direction of what? Along the direction of R. Yes or no? So what is happening? See here, if the force and R, if they are perpendicular, then only will the rotational effect will be more. Are you understanding? If I go on decreasing the angle, then the turning effect will be less. So it depends upon the angle also. And which component? It depends upon sine theta. F cos theta is nothing to do with the torque, because horizontal component will contribute nothing to this torque. So only we consider torque as a cross product. What is a cross product? When A and B, what are A and B here? R cross F are perpendicular to each other. So R is this, F is this. When they are perpendicular to each other, that only will give rise to torque. When R and F are parallel to each other, then in that case torque will be zero. In that case torque will be zero. Are you understanding? I need to apply force in this direction. This is my R. This is R. This is force. What is the angle? This. If R is this, force is this, will it give a rotational motion? No, it is giving you what? A linear motion, a linear motion. But what if I increase this force in this direction, perpendicular? It is giving you a turning effect. It is giving you a turning effect. Got it? So when R and F are perpendicular, which perpendicular means which component you should take? F sine theta. And that N is giving you what? Unit vector. All of you are understanding? Got it? Okay, fine. So we little bit understand what exactly is the direction of the torque. Now always remember, unlike I told you, whatever angular quantities are there, whether it might be angular acceleration, angular velocity, they are always perpendicular to the circular motion. Similarly, torque is also perpendicular to the plane containing R and F. Are you understanding? The direction of the torque is perpendicular to the plane of R and F. Like for an example, if this is R and this is somewhere F at any angle theta. Okay, so what will be the direction of the torque? What will be the direction of the torque? So for that we'll again use which rule? Which rule? Right hand Calb's rule. Okay, so when we take right hand Calb's rule, all of you understanding, right? When I close R with F, you have to always consider the smaller angle. R cross F means don't take this angle. You should always consider the smaller angle. So R and F. So it is going R with F. So thumb gives you the direction of what? The thumb gives you the direction of the torque. When I do F cross R, when I do F cross R, they go F say R, F and R. So this thumb is giving you what? Direction of the torque. So it is always perpendicular to R and F. Are you understanding? Or you can use screw rule. You can use screw rule. What is screw rule? What exactly is screw rule? I had told you in the last class also, right? When you do all of you, when I do R and F, if I rotate it anti-clockwise, suppose if I have screw and you do what? R say F, R say F. Imagine this, if I have one screwdriver and I want to fix it. So what I am doing is R with F. R with F means which direction? Anti-clockwise direction. Anti-clockwise. Are you understanding? R with F. So in that case, what is happening? Anti-clockwise direction. What is happening? The screw will come out, right? The screw will come out. Yes or no? How does the clock rotate? How does the clock rotate? This way. If I do anti-clockwise, R and F, I'm just closing anti-clockwise. So screw will come out. If I do clockwise, F and R, screw will become tight. Anti-clockwise, screw will come out. Clockwise, screw will go down. Yes or no? So R and F are rotating here and it is going outwards or inwards. What does it mean? It is perpendicular to the plane of R and F. It is perpendicular to the plane of R and F. So what is the direction of torque? It is outward. Yes, it is perpendicular. Outward, in which case? Anti-clockwise. Anti-clockwise direction. And torque will be inward in clockwise direction. So perpendicular concept you understand by Calb's rule, and outwards and inwards you can understand by screw rule. When you do anti-clockwise, when you rotate R and F, the screw will come out. When you do F and R, it is going inwards. Okay, it goes inwards. So conventionally we take anti-clockwise direction positive here, and here we take negative here. In the textbook they have given it's a conventional direction. Okay, have you understood the concept of torque? Okay, so again the torque will be maximum when the angle between theta is 90 degree, and the torque will be minimum, that is 0, when theta is 0 degree. When theta is 0. Have you understood the concept of torque? Okay. So next concept we are going to study is the angular momentum. Angular momentum. So next concept is angular momentum. So what is angular momentum? The moment of momentum. The moment of momentum is called angular momentum. So the moment of momentum is called as what? Angular momentum. What is moment? Torque. And torque's momentum is called as what? Angular momentum. So in straight line you have studied a concept of momentum. What is momentum? Momentum is product of mass into velocity. So what this momentum was telling you? Momentum was telling you the quantity of motion. How much is the motion? If you just want to know what is the motion, you consider velocity. But if anybody asks how much is the motion, what is the quantity of motion, then this is momentum. Like if two objects are coming with certain velocity, 10 meter per second, 10 meter per second, but those two objects, in that two object, one is elephant and one is ant. So elephant will obviously it has more mass, so it will carry more momentum, whereas ant has a less mass, so it will carry less momentum. So what momentum is telling you? Momentum is telling you the quantity of motion, how much big is the motion. Okay, now this momentum we used in a linear object, and this angular momentum will tell you what? A rotational motion. In rotational motion. So the quantity of rotational motion is called as angular momentum, or the moment of momentum is called as what? Angular momentum. The moment of momentum is called as what? Angular momentum. Now little bit let us try to understand. Like again the same thing. Take the nut bolt or like example only. You need to fix this nut. You just want to open it or close it. Okay, open it anti-clockwise, close it. Open it anti-clockwise and close it clockwise direction. This thing is clear. So what you do is you apply the force. You apply the force. Now how much quantity of force you are applying, how much mass is involved here, that will give you what? Angular momentum. Okay, so again an angular momentum is very good example of cross product, which is denoted by L cross. In some textbook angular momentum is denoted by J. So what is L? L is angular momentum and it is given by what? R cross tau. R cross tau. R cross tau. Okay, sorry. R cross P. Sorry. R cross P. So the moment of momentum is called as what? Angular momentum. The moment of momentum is called as what? Angular momentum. Are you understanding? So what was this P? See, what was this P? A linear momentum. Multiply R, it will give you what? Angular momentum. So I can write angular momentum as what? L equals to R cross. What can I write P as? P can I write mv? You can also reduce this formula as R cross P cross sine theta with n cap. Okay? With n cap, because it is a cross product. Can I write P as mv, where v is vector quantity? So I can again reduce this. M I can take outside and can I write R cross V? Okay, because M is the scalar quantity. So angular momentum is given by M R cross V, or you can simply write R cross P. What is angular momentum? It is moment of momentum is called as what? Angular momentum. Have you understood? Now there is very big concept of conservation of angular momentum that we are going to study in the next class. Now we are going to study, again you can get the SI unit of this. What is SI unit of angular momentum? It is, momentum is kilogram meter per second, and this meter will be kilogram meter square per second. Can I write dimensional formula of this? It will be what? M1 L2 T minus 1. Again it is a vector quantity. Okay, you can also write it as L R cross M V perpendicular. V perpendicular. Again it is perpendicular to the plane containing R and T. Got it? Same like your torque. Okay. So have you understood what exactly is angular momentum? Angular momentum is not a complicated topic. You can just relate angular momentum with the linear momentum, just multiply R. Now here we are going to do very important derivation, that is relation between angular momentum and torque. I request you ki you can take out your books and do this derivation along with me, because this derivation they will ask you for 5 marks. This is a very important derivation for 5 marks, or in some cases they may ask this question for 3 marks. They can collab one question along with this and they can give you this question for 5 marks. Now, what exactly is the relation between angular momentum and torque, that we are going to do it. Now, all of you know what is angular momentum? L cross. L is equal to what? R cross P. L is given by what? R cross P. Yes or no? So, give this as equation number 1. I'll write that equation. So, we'll see ki we complete that derivation within this board. So, what is L equals to R cross P, angular moment. Give this as equation number 1. Now differentiate this equation with respect to t. We are going to differentiate this equation with respect to time. Differentiate equation 1 with respect to time. So I think you might have studied differentiation. Even if you are not studied, don't worry, in mathematics, probably in the second year you will be studying differentiation. Now whenever the differentiation formula is required, I will be telling you. Okay, fine. Now how to differentiate it? I think little bit in straight line you might have come across the differentiation and integration. Okay, so now we are going to differentiate this equation with respect to time. So what is differentiation? dl by dt equals to d by dt r cross p. Now here we are going to differentiate this equation. Okay, Now there is one rule which we call it as multiplication rule. We are going to apply multiplication rule, or we usually call it as a UV rule. Okay, we are going to use multiplication rule or UV rule. I'll just tell you what exactly is multiplication rule, then you try to apply this. Okay, so if I have U and V, and it is a product rule, okay, a multiplication rule, product rule. So what is the method here? First you need to differentiate first term, keep second term as it is, plus differentiate second term and keep first term as it is. See, look how it goes. Du by dt, first term, into second term I'll keep as it is, plus differentiate second term and keep first term as it is. Are you understanding? This is called as multiplication rule. Yes or no? Is a multiplication. So let us apply that here. dl by dt equals to d by dt. Now multiply, differentiate first term. What is first term? dr into what is second term? p. You can put arrow, okay, or else you can later you can put, plus differentiate second term, dv by dt. Second term is what? dp by dt. What is first term? r. Are you understanding? UV rule. You can copy that UV rule at the side. Okay, simple rule. Differentiate first term, keep second term as it is, plus differentiate second term, keep first term as it is. Have you understood? Okay, now go on reducing this equation. So dl by dt equals to dr by dt. What does dr by dt gives you? Rate of change of position. R is changing, right, with respect to time. Rate of change of position. Will it not give me a velocity, which is again a vector quantity, dot p plus dp by dt. For my convenience, I'll keep r at this side. R dp by dt. Have you understood what did I do here? dr by dt will give me what? Velocity. So again, dl by dt. Shall I erase this better? I'll erase this. Okay. I'll better erase this. Okay. So see here. So I'll write the dv rule once again. So that dl by dt will give you what? R cross p. No, dr by dt give you what? Velocity. P as it is, plus r dp by dt. Is it not? This was the equation, right? Okay. Now again, dr by dt got me what? Velocity. So dl by dt. What is v? V is as it is. What is p? P is momentum, m cross p. M cross, it's a cross product, right? M cross v plus r dp by dt. Are you understanding what did I do here? I have written P as mv, because P is what? Momentum. P is momentum. Momentum is given by mass into velocity. Now dl by dt equals to 0 plus r dp by dt. R dp by dt. Because what is v cross v? Is it not a 0? V cross v, cross product property. If two vectors are parallel to each other, then the cross product between those two vectors will be 0. Yes or no? Like see here, A and B. What is cross product A and B? Here will be 1, because angle between them is 90 degree. That is AB sin theta. If A and B are along the same straight line, if they are parallel to each other, what is A cross B? Sin theta will be 0 degree. So A cross B will be 0. So similarly, V cross V, what does it mean? V cross V. V and this V are along the same direction. So V cross V will be what? 0 degree. Yes or no? It will be what? Not 0 degree. The product will be what? 0. Those who are not understanding this thing, this already it is covered in a motion in plane topic. Please go through it. Dot product and cross product. So V cross V. Here V cross V will be 0. And 0 into M will be what? 0. Got it? V cross V will be 0. Got it? V and this V are are parallel to each other. So what do I get here is dl by dt equals to r dp by dt. R dp by dt. Got it? Now what is dp by dt? dp by dt is rate of change of momentum, And if you understand Newton's second law, what did it state? Newton's second law of motion. The rate of change of angular momentum is directly proportional to the applied force. So this rate of change of momentum is nothing but the applied force. Is it not? So write somewhere at the corner कि dp by dt is nothing but what? Force. So rate of change of angular momentum is equal to the applied force. So what do I get here? dl by dt equals to r. It's a multiplication. Which multiplication? A cross product multiplication. R cross F. So what is dl by dt? dl by dt. R cross F is nothing but what? Is it not a torque? So what is the relation between angular momentum and torque? The rate of change of angular momentum is equal to torque. That's what you have studied in Newton's second law. Rate of change of angular momentum is force. Rate of change of linear momentum is force. Rate of change of angular momentum is torque. Rate of change of angular momentum is torque. Are you understanding? So this is the 5 marks very important derivation which you can expect in your exam. Okay, or they may ask for 3 marks because it's not that lengthy derivation also. Have you understood this? Have you understood this concept? Please remember those small things whatever I have told you. Don't forget that UV rule, and remember, if the cross product of two vectors, if they are parallel to each other, if they are in same direction, if the angle between them is 0 degree, then straight away write it as 0. So if you are writing 0, then what you are left with? This. What is dp by dt? Force. Rate of change of momentum will give you what? Force. And force will, what is this? R cross F, torque. So rate of change of angular momentum will give you what? Torque. Okay. So this is what for today's class. Okay. So what we have studied? What is torque? Torque is the turning effect of an force which is along the axis of rotation. How it is given? By R cross F sine theta, given with an n cap, which is a unit vector. What is the direction of the applied torque? It is perpendicular to the rotational effect of R and F. Then it's a vector quantity, and we have studied its SI unit is Newton meter and dimensional formula. Then study what is angular momentum. It is moment of momentum, which is given by L equals to R cross P. Then very important relation between angular momentum and torque. How do you start that derivation? Just write angular momentum as R cross P and just go on differentiating this with respect to time. So dr by dt will give you velocity, and this velocity with this velocity will become 0. So you are left with this thing. Apply UV rule and get this derivation. Okay. Have you understood? Okay. So in the next class we are going to study the concept of conservation of angular momentum. Already you have studied conservation of linear momentum. I would better suggest you to study and come conservation of linear momentum. So as usual, I am expecting one homework from you. Okay. I am expecting you to write the conservation of angular conservation of linear momentum in the comment section. Okay. So if you study and come the conservation of linear momentum, then you will easily understand the conservation of angular momentum. So those who knows this statement, the conservation law of linear momentum, write them in the comment section. So that we'll meet in the next class. Thank you.